In this video, we will do some problem solving and apply the properties of pairs of reciprocal functions. So if we have a function f of x, which is a quadratic, and g of x, which is the reciprocal of the quadratic, f of x is much easier to work with. Okay, we are now very familiar with quadratics, very familiar with polynomials, and this is what we will like to use to answer questions about g of x. So if we're asked when g of x will have a vertical asymptote, we know that g of x has vertical asymptotes when f of x has an x-intercept, or when it equals 0. So when does x squared and 2x equal 0? Well, this is a polynomial equation that we can solve by taking a common factor and then identifying that the roots or solutions are at -2 and 0. So that means g of x has vertical asymptotes when x is -2 and 0. F and g intersect when f is 1 or -1, because the reciprocal of 1 and -1 is itself, and that is the only number whose reciprocal is itself. So when does f at x equal 1? When does x squared and 2x equal 1? To solve this polynomial equation, we will set it equal to 0. And factoring isn't a possibility. Nothing multiplies to -1 and adds to 2. So we will use the quadratic formula. So 4 minus -1, so -2 plus or minus root 8, which simplifies to 2 root 2 over 2. So we got -1 plus or minus root 2. So there are actually two x values that have a y of 1, so this will create two intersection points. And when does x squared and 2x equal -1? Or x squared and 2x plus 1 is 0. And great news, this is a difference of, this is a perfect square trinomial. So x plus 1 squared is 0, or x is -1. So there is one x value that gives us a y value of -1. So then f and g intersect at 3 points. So the first point, our x value will be -1 plus root 2. And remember, our y value was 1. Okay, our next point will be -1 minus root 2 with a y value of 1. And our third point has an x value of -1 and a y value of -1. So 3 points where these two graphs will intersect, and only these 3 points. G will have positive intervals when f has positive intervals. So when f at x is positive. So when is x squared and 2x positive? Again, the factored form will help us, but we still need to sketch this. So intercepts at -2 and 0, positive even degree, positive leading coefficient, even degree opens up. So we can see f at x is positive until -2 and from 0 on. So g of x is positive for that exact same interval, -infinity to -2 and 0 on. Where will g of x be increasing? That will be when f at x is decreasing. Okay, increasing and decreasing is a calculus concept. So next semester, if you take calculus, you'll be able to figure this out algebraically. But at the moment, we just need to look at a graph to tell when our function is increasing and decreasing. So this parabola is decreasing until its turning point. And so that turning point is halfway between its two zeros. So this function is decreasing from -infinity to -1. Okay, so then g of x is increasing for the same interval, except remember that there's an asymptote in that interval. So it is increasing from negative infinity to negative 2 and negative 2 to negative 1. So not the exact same interval, because remember g of x has a restriction on its domain, and so we have to not include the value for the VA. Okay, next question asks us to find a possible equation to represent the functions. So note that two key properties, there's a VA at 5 and an HA at 0. When you have a horizontal asymptote at 0, for now, based on what we know, this means a function that is reciprocal, so 1 over something. And we're going to get this vertical asymptote here when the function in the denominator has an x-intercept. So what function has an x-intercept of 5? It's the function x minus 5. Okay, because we can see if you plug 5 in for x, we'll get 1 divided by 0. That doesn't exist, and we'll create the vertical asymptote. Okay, we don't know an a value. I haven't given you any points here, so we're just going to leave the function like this. For b, we notice two VAs at x equals minus 1 and x is 2, and a HA at y equals 0. So we know our function is reciprocal. And to get VAs of negative 1 and 2, mean in our denominator we have to have x plus 1 and x minus 2, so that when we sub in these two numbers, we get 1 divided by 0 to create our vertical asymptote. Finally, we're going to use a function to state the properties of the reciprocal. This function is linear. So to find the vertical asymptotes of the reciprocal is at the x-intercepts of this function. So when does negative 3x plus 9 equals 0? This is a linear equation. So this happens when x is 3. All reciprocal functions have the end behavior as x approaches plus or minus infinity, y approaches 0. You can say that they have a horizontal asymptote at y equals 0. Reciprocal functions will have the same positive interval as your line. So negative 3x is greater than negative 9, or x is less than 3. So we are dividing by a negative and reversing the sign. The negative intervals will be when your line is less than 0 or greater, x's are greater than 3. The increasing intervals on your function come from when your reciprocal come from when your function is decreasing. This line is entirely decreasing. So on your reciprocal, there will only be increasing intervals. There will be no decreasing intervals. And this is decreasing for XER. So this would be increasing for XER, except there's an asymptote at 3 that we have to remove, because when x is 3, the function does not exist. It is not increasing. So here are some applications of how we can use the properties to tell us about a reciprocal function and even write the equation of a reciprocal function. So good luck practicing.